Welcome to Lecture 3 of Technical Mathematics, Matrices and Determinants, Part 3. In this lecture, we are going to discuss about properties of determinants and identification of matrices. We will solve few previous year exam questions related to these topics. Let's begin our discussion with properties of determinants. Property number 1 of determinants says that determinant of A transpose is equal to determinant of A itself. That is, determinant of transpose of a matrix will be equal to the determinant value of the actual matrix itself. Let's prove this property using an example. Suppose we have a matrix A equal to 1, 2, 3, 4. Then what will be transpose of this matrix? A transpose will be equal to, the first row will be the first column of A, so it is 1, 3. The second row will be second column of A, so that is 2, 4. Now let's calculate determinant of A and A transpose. Determinant of A will be equal to 1 into 4 minus 2 into 3. So that will be equal to 4 minus 6, that is minus 2. Now let's calculate determinant of A transpose. Determinant of A transpose will be equal to 1 into 4 minus 3 into 2. 3 into 2. So that will be 4 minus 6 equal to minus 2. So you can see that determinant of A transpose and determinant of A are equal. Both are equal to minus 2 here. So this proves property number 1 of determinants. It says that determinant of transpose of any matrix will be equal to determinant of the actual matrix itself. Okay, now let's move on to property number 2. Property number 2 of determinants says that determinant of A prime will be equal to minus of determinant of A. So here A prime is a matrix obtained by interchanging any two rows or columns of A. So A prime is a matrix obtained by interchanging any two rows or any two columns of A. So the new matrix A prime will have a determinant value which is equal to minus of determinant of the actual matrix. So that is what property number 2 says. Let's prove this using an example. Suppose our matrix A is equal to 1, 2, 3, 1. Then if I am interchanging row 1 with row 2, suppose I am going to do a row manipulation like this. Row 1 is exchanged or interchanged with row 2. If I do such an operation, the resulting matrix is taken as A prime. A prime will be equal to 3, 1, 1, 2. So row 1 and row 2 got exchanged, and now we have a new matrix. Elements are 3, 1 and 1, 2. Now let's calculate determinant of these two matrices. Determinant of A will be equal to 1 into 1 minus 2 into 3. So that will be equal to 1 minus 6, which is equal to minus 5. Now let's calculate determinant of A prime. If you calculate determinant of A prime, you will get it as 3 into 2 minus 1 into 1. 1 into 1. So that will be 6 minus 1, which is equal to 5. So we can see that the determinant of A prime is equal to minus of determinant of A. So here it's minus 5. Determinant of A is minus 5. So minus of minus 5, that is plus 5. So that is what we are getting as determinant of A prime. Determinant of A prime, we are getting it as plus 5. So this proves that determinant of A prime, that is a determinant of a matrix obtained by interchanging any two rows or columns will be equal to minus of determinant of the actual matrix. Okay, so this is what property number 2 says. Now let's move on to property number 3. Property number 3 of determinants says that if two row or column elements are same, then determinant value is 0. So if two rows or two columns are same, then determinant is 0. So here if we have a matrix like this with row 1 and row 3 having equal elements or same elements, then the resulting determinant will be equal to 0. So let's see an example. Here in this matrix we are having row 1 elements as 1, 2, 3. Row 3 is also having elements 1, 2, 3. So therefore determinant of this matrix will be equal to 0. So it's a very important property. Now let's move on to property number 4. Now property number 4 says if we have a common factor in any one of the rows or columns of the matrix, then calculation of determinant can be simplified by taking out that common factor outside and then finding the determinant of the remaining elements. Finally, after determining the value of the determinant, we have to multiply this determinant value with k to get determinant value of the actual matrix. So let's see an example. Here in this example we have 3, 6, 9 as elements in row 3. We know that 3 is a common factor in all the 3 elements. So we may take out 3 outside and then we rewrite row 3 as 1, 2, 3. Now find out determinant of this new matrix, multiply that with 3, we will get determinant value corresponding to the actual matrix. So this is what property number 4 says. Now let's try to solve this. If we are calculating determinant value of this one, it will be 0 because row 1 and row 3 right now are having same elements. So therefore this will be equal to 3 into 0, that is equal to 0. So without using the conventional method of finding out determinant of a 3 by 3 matrix, we are using properties of determinant to solve this problem. So in a single step we are getting the answer. Just by observing the matrix we may find out the answer. So this is the usefulness of properties of determinants. Okay, now let's move on to property number 5. Property number 5 says if any row or column of a matrix is added with elements or multiplied versions of elements of another row or column, then determinant will remain the same as that of actual determinant of the matrix. So let's see this case. Here we have row 1 elements as A, B, C. Row 2 is having elements D, E, F, and row 3 is having elements G, H, I. Now if we are doing a row manipulation like this, suppose R1 is changing to R1 plus 2R2. So here this second part 2R2 is nothing but multiplied version of row 2. It is multiplied version of row 2. Okay, so we are changing row 1 to row 1 plus 2R2. So let's see how this matrix is getting modified. You may see that A is getting modified as A plus 2D, A plus 2D. B is getting modified as B plus 2E, and C is getting modified as C plus 2F. So property number 5 says that even if we do such a row operation, the resulting determinant value is same as that of the determinant of the actual matrix itself. So here there is a constraint. We should not mix column and row operations. Row and column operations should not be mixed. If we mix them, the value of the determinant is going to change. So if we are not mixing up column and row operations, and if we are doing either row operations alone or column operations alone, then determinant value will be same as that of the actual matrix. So that is what property number 5 says. Okay, so based on the properties what we discussed, let's try to solve few problems. Question number 1, calculate the value of the determinant. So here we have a matrix. We are asked to calculate the determinant value. We have 4 choices. Option A says 0, option B says 1, option C says -1, and option D says 2. So you may try this by yourself. Please pause the video and try to solve this by yourself. Try to make use of the properties what we discussed just now. Okay, now if you have the answer, you may check the answer. Here the right answer is option A, 0. Let's see how to solve this. Okay, here if you closely observe this matrix, you can see that the value of elements in row 3 is equal to the sum of row 1 and row 2 elements. Say suppose if you take this first element in row 3, that is 5, it is sum of 1 and 4. And if you take the case of second element 7, you can see that it is sum of 2 and 5. And this third element 9, it is sum of 3 and 6. So row 3 elements are having values equal to the sum of elements in row 1 and row 2. So let's make use of property number 5 here. Property number 5 says that even if we manipulate a row in terms of another row or multiplied version of another row, the value of determinant is not going to change. So here I am going to rewrite R1 in terms of R1 and R2. I am going to rewrite it as R1 plus R2. So determinant value should not change as per property number 5. And when I do this manipulation, this 1 changes to 1 plus 4, that is 5. And this 2 changes to 2 plus 5, that is 7. And this 3 changes to 3 plus 6, that is 9. And the other 2 rows remains the same. Okay, so row number 2 will have elements 4, 5 and 6. Row number 3 will have elements 5, 7 and 9. So as per property number 5, this determinant value should be same as that of this one, the actual determinant. Now if we look into this new matrix, you can see that row number 1 and row number 3 are having same elements. Therefore, as per property number 3, determinant of this new matrix will be equal to 0. Property number 3 says that if any two rows or any two columns are having same elements, then determinant of that matrix will be 0. So here row 1 and row 3 are having same elements, therefore this determinant value will be 0. And therefore the determinant value of this actual matrix will be also equal to 0. So here the right answer is option A, 0. Okay, now let's move on to question number 2. Question number 2 says, find value of the determinant given below. So we have a matrix here. We are asked to calculate value of the determinant. Option A says 0, option B says 1, option C says -1, and option D says answer is 2. So please pause the video and try to do this by yourself. Okay, try to make use of the properties what we discussed. Okay, now here the right answer is option A, 0. Let's see how to solve this. Here also we may make use of property number 3 and 5 once again. Here if I replace column number 1 in terms of column number 1 and column number 2, the value of determinant should not change. That is what property number 5 says. So here if I rewrite this determinant as determinant of sin square theta plus cos square theta, sin square theta plus cos square theta as per this manipulation. Okay, now column number 2 remains the same, cos square theta itself, and column number 3 also remains the same, its value is 1. Now second row, first element will change as cos square theta plus sin square theta. So this will become cos square theta plus sin square theta. Second column remains the same, sin square theta. Third column also remains the same, 1. Now this one, third row, first element will change as 2 plus -1. So that is +1, and this one will be -1 itself, and the last element will be again 1. Now here this matrix, what we have here may be rewritten as, we have sine square theta plus cos square theta here, that may be written as 1. Then we have cos square theta, then we have 1. Now here we have cos square theta plus sine square theta, that becomes 1. Then we have sine square theta here, and then we have 1. Now here we have 1 minus 1 and 1. 1 minus 1 and 1. So this determinant value should be same as that of this one, which is same as that of this one. Now here if you observe this matrix, you can see that column 1 and column 3 are having same elements. Therefore, as per property number 3, the value of the determinant will be equal to 0. Property number 3 says that if any two columns are having same elements, then the determinant value of such a matrix will be 0. So here column 1 and column 3 are having same elements, therefore determinant value will be equal to 0. So here the right answer is option A. Now coming to question number 3, the value of determinant given below is 0. Then K is, okay, we have a matrix here. We are asked to calculate the value of K, the unknown in the matrix. We have a hint that the value of the determinant is 0. So try to solve this by yourself. Please pause the video and try to solve this by yourself. Okay, now if you have the answer with you, you may check the answer. Here the right answer is option C, 2. Okay, let's see how to solve this. Here again we may make use of property number 5 and 3 to solve this problem. Okay, if you closely observe this matrix, you can see that the value of elements in column 3 are equal to value of elements in column 1 and column 2. Say if you take the first element in column 3, you can see that it is sum of 1 and 2. 3 is sum of 1 and 2. Similarly, the second element in column 3 is 5 and its value is sum of 3 and 2. Okay. Similarly, if K, if it is 2, then we will get 2 plus 2 equal to 4. So if the column 1 changes to column 1 plus column 2, then this determinant will change as 1 plus 2, 3, 2, 3. Then this element will change as 3 plus 2, that is 5. Then we will have 2 and 5. And this will change as K plus 2, K plus 2, 2 and 4. Now we know that as per property number 5, even if we make a column manipulation like this, the determinant value will be same as this determinant value, and in the question it is given that the determinant value is 0. So here if you observe this matrix what we have here, you can see that here column 1 and column 3 are having same elements except in this position. Okay, so here we have 3, here also we have 3, here we have 5, here also we have 5. So if this K is 2, then definitely this element would have been 4. So here in the options we have option as answer 2. Okay, so therefore the right answer will be 2. That is, if this K is 2, definitely this determinant value is going to become 0. Okay, so like this way we may solve the problem without going for the complex calculations what we have learned in case of a 3 by 3 matrix. Okay, there is no need to calculate the determinant value using the complex method what we studied. Okay, now let's discuss about few special properties related to determinants. First one, determinant of a diagonal matrix is equal to product of diagonal elements. So if we have a diagonal matrix like this with main diagonal elements as A, B and C, then determinant of this diagonal matrix will be equal to A into B into C. Now the second property says Determinant of an upper triangular matrix is equal to product of diagonal elements. We know what is an upper triangular matrix. An upper triangular matrix will look like this. All elements below the main diagonal are zeros. So in an upper triangular matrix, if diagonal elements are A, D and F, then determinant value will be equal to A into D into F. This is true in case of lower triangular matrix also. The determinant of a lower triangular matrix will be also equal to product of diagonal elements. Okay. Now let's see one question. Question number 4. Let A be a 3 by 3 matrix. Suppose that the matrix B is obtained from A by the following row operations. Row 1 interchanges with row 2. Row 3 changes to row 3 plus 5 into R1. If determinant of A is 12, then determinant of B is. So you may try to do this by yourself. Please pause the video and try to solve this by yourself. Okay, now if you have the answer with you, you may check the answer. Here the right answer is option B, minus 12. Let's see how to solve this. Here it's mentioned that we are performing two row operations. The first row operation is a interchange between row 1 and row 2. So as per property number 2, if we interchange any two rows, then the resulting matrix will be A prime, and determinant of A prime will be equal to minus of determinant of A. So here determinant of A is given, it's 12. So therefore the resulting matrix will have a determinant which will be equal to minus 12. Okay. Now following this operation, we are doing another operation, that is row 3 changes to row 3 plus 5 into row 1. So as per property number 5, if we make any row manipulation like this, the determinant value is not going to change. So therefore the determinant value will remain same as that of minus 12. So when we perform the first row operation, determinant value will become equal to minus 12, and following which if we do this second operation, the determinant value is not going to change as per property number 5. So here the right answer is option B, minus 12. Now let's discuss about few types of matrices. The first one is singular and non-singular matrices. If determinant of A is 0, then A is a singular matrix. So matrices with determinant value equal to 0 are called singular matrices. Now if determinant of A is not equal to 0, then A is a non-singular matrix. Okay, now nilpotent matrix is a matrix which follows this criteria, that is A raised to P equal to 0. So here A is a matrix and P is a constant. It is nothing but nilpotent index. Okay, so P is taken as the smallest value for which A raised to P becomes equal to 0. So sometimes A may not be 0. We will have a value for the matrix. Now when you multiply A with A, that is when we perform A into A, we may be getting a 0 matrix. So in that case, A raised to 2 has become equal to 0, and therefore 2 is the nilpotent index. Now idempotent matrix is the one which follows this criteria, that is A square equal to A. A square equal to A, that is A into A becomes equal to A itself. So such a matrix is called idempotent matrix. Now involutory matrix is the one which follows this criteria, that is A square equal to I. I is the identity matrix. So if we have a matrix A, when we multiply A with A, if we are getting identity matrix I, then A is a involutory matrix. Okay. Now let's see one question. Question number 5. If a matrix A is symmetric as well as skew symmetric, then option A says A is a diagonal matrix, Option B says A is a null matrix. Option C says A is a unit matrix. And option D says A is a triangular matrix. So please try to solve this by yourself. Please pause the video and try to solve this. Okay, now if you have the right answer, you may check your answer. Here the right answer is option B, A is a null matrix. Let's see how to solve this. Here in the question it is given that matrix A is symmetric. Matrix A is symmetric. So it means that A transpose is equal to A. Okay, now it's also given that matrix A is skew symmetric. So it's also a skew symmetric matrix. So symmetric and skew symmetric at the same time. So skew symmetric matrix is the one where we have A transpose equal to minus A. So here LHS are same. So if you substitute or if you equate right hand sides, then what we get is A is equal to minus A. So this criteria is followed by null matrix alone. Among these four, A equal to minus A. That criteria is satisfied by null matrix only. So therefore here the answer is option B, A is a null matrix. Okay, now with this we are coming to end of lecture 3. In lecture 3 we discussed about properties of determinants and also we familiarized few types of matrices. In lecture 4 we will continue with matrices and determinants. We will discuss about minor of a matrix, cofactor of a matrix, adjoint of a matrix and inverse of a matrix, and also we will discuss few questions related to these topics. For upcoming videos you may subscribe to Vadhyar Online Academy on YouTube, and for study materials you may subscribe to our Telegram channel using this link, and we have provided this link in the description of this video. So thank you. See you in lecture 4. Goodbye.